Unit 3, Lesson 2A. So it's our second lesson, too. It's the applications lesson. So we're going to go into finance now. So investing money, we're going to compare simple interest and compound interest for this lesson. So first off, we'll just start with simple interest. So simple interest is usually applicable into short-term investment of 1 year or less, not really longer term, where annual interest is paid to the investor and not reinvested. So you just kind of get that much money, but it's not reinvested. It's almost like when you get your interest, you just put it in your pocket. You don't put it back in the account. So if you invest $500, which earns interest rate of 6% per year, how much interest would you earn? So this is just kind of understanding 1 year, half a year, or semi-annually, 1 month, okay? So you simply, for 1 year, it's just you get the full percent. You get the full 6% for the year. Times, yeah. Maybe we can do brackets would be better. 500 times 0.06 for 6%. So you'd make $30. Okay, for half the year, you do 500 times 0.06, but times 1/2. So you only get half that percent. You only get 3%. So then that would get you the $15. And then 1 month, you get it 500 times 0.06 times 1/12. And so then that would be $2.50. Yeah, a lot of money. Get yourself a cup of coffee. Okay. If R is an annual interest rate expressed as decimal and money for principal is the initial investment, calculate how much interest would be earned in 1 year. So they're just thinking about in terms of P and R, so not with numbers. So for 1 year, it would just be P times the rate. Half a year would be P times half the rate. And then for T years would be P times TR, or PRT, as you see right below. I would say that when it comes to the finance stuff, they assume that you know what the variables are, so make sure you kind of refresh these variables. So I is interest, P is principal, R is rate, and T is time. Okay? Makes much more sense. Okay? So I is interest, P is principal. Remember, principal is your starting amount that you start with. R is the rate you're getting, and T is the time. Okay? So let's use a couple of more examples, and then we're going to talk about compound interest a little bit, and we'll compare the two. Okay, so Millie invests $2,350 at 7% per year for 6 months. Calculate after 6 months the simple interest she would get. So if she did for 6 months, she would have $2,350 times 0.07 times 1/2, because she's only doing it for 6 months. And so she would get $82.25 on her investment. And right, so the value of her investment is now what she has total, so you'd add the 82 to the 2350. Yep, so 2350 plus the 82.25, so she's got 2432.25. Okay, that's just a quick little run through with simple interest, very basic. Okay, compound's a little bit more exponential. Okay, so in simple interest, the principal at the beginning of the second year is the same as the principal at the beginning of the first year. So what happens there, it doesn't reset, because like I said, you're pocketing that money, so it's not compounding on what you made. So in compound interest, the interest earned during the first year is added to the original, so you're putting it right back to the account, and now you're building off of that. So it's compounding. That's where it kind of comes from in terms of the word. Okay? So simple is just like you're just trying to make money. So obviously simple interest would be good if you're someone who has a lot of money, let's say, and you're just living off your interest, essentially. Like some people have enough money that the interest in the bank sometimes could pay a mortgage for them. You know what I'm saying? So when you have that much money, that's ridiculous, but that would be a simple interest example. Okay? So to understand the comparison between simple interest and compound interest, do this investigation in the next few pages. This is a little bit redundant, guys, so I'm going to go through it, but you just kind of hang in there. So we got a regular savings bond, which pays 9%, and a compound savings bond, which offers 9%. So we'll do the simple interest first. So here's a simple interest table. So with simple interest, 9% of 5,000. 9% of 5,000 is 450. And so what this means is that every year you're just going to make $450. Simply, that's all you're going to do. So first year, your value is 450, so you made 450 from 5,000. Second year, you're up to 900. So third year, you're up to 6,350, 6,800, 7,250, 7,700, 8,150, and then 8,600 is your simple interest gain over 8 years. It's a really good rate in terms of gaining. Like if about investment, if investments get 9%, that's really high in terms of that kind of stuff. But there's definitely stocks and stuff, mutual funds that are higher than that. But if you just think about it, if you can tell me, obviously 5,000 is a ton of money, but if you're doing something bigger than that, let's just say 50,000, and you almost double your money in 8 years, that's pretty good. Okay, so not bad. Find the value of the bond at the end of each of the first 8 years, so we did that. Okay, so now let's go ahead and look at the compound interest. So with compound interest, we kind of set it up more as an exponential. So we have, they're kind of showing you how it's set up, and then they're going to give you the formula. But 5,000 plus 5,000 times 0.09. So the 0.09, 5,000, sorry, that is representing the interest rate. So what are you getting? So the $450. And what they do is, this step here, people get confused on. They pull a 5,000 out. See how there's a 5,000 in common? And so then it's 5,000 times 1 plus 0.09, which gives you 5,000 times 1.09. Now 5,000 times 1.09 makes sense because that's telling me how much will I have after 1 year of 9%. Because if you just do 5,000 times 0.09, you're just going to get the money, they have to add it. This takes care of that for you in the problem if you do 1.09. Okay, so then year 2, you're going to have 5,000 times 1.09 plus 5,000 times 1.09, 0.09. Okay, because it's 2 of these, 1, 2, and then 9% of what you have now. See how it's compounding? Let me say that again. Here's the 2, okay, for 2 years. And then what happens now is we want to make 9% off the new value. And so then you're adding that. So then see, what do they have in common? They have in common a 5,000, 1.09, so we pull that out. And now again, it's 1 plus 0.09. And so you can see, this is essentially what begins the formula. So it's essentially the principal times the 1 plus the rate to the year. No, they're not putting. See, that's nope. They're not putting 5,000 more in their account every year. What they're putting in their account is what they made the previous year. Okay, so see right here, 5,000 times 1.09. That's what they made year 1. And then we're adding what we're making year 2. So like, see how the 0.09? That 0.09 is going to make this go small. Do you see that? See, 5,000 times 1.09 is how much I have after year 1, and I'm doing 9% of that, which is going to make that a small number. And I'm going to add, and that's going to add to get me my new value. So it's not another $5,000, no. But see, the formula builds it a little bit easier for you. You don't have to really worry about writing all this out. Once you get the formula, we're just showing the formula. So if you look at this, let's look at year 3 now. So year 3 would be, okay, so it would be 5,000 times 1.09 squared plus 5,000 times 1.09 squared, 0.09. See, it's the what you have now plus what you have now, 9%. That's 9% of the new year. And so again, you pull out the 5,000, 1.09 squared, and then you have 1 plus 0.09 again. And so then you see you have 5,000. I don't think you need the 4th step here, right? 1.09 cubed. Because you have 1.09 and that's a 1.09. So it's cubed. For 3 years, principal times 1 plus the rate cubed.
That's how much money you were, that's your
Correct. This is your end total bank account after year 3, after kicking back in the interest every year. So you're throwing the interest back in the account every year, and it's compounding and adding from there. So that's why compounding is going to make you a little bit more money, because you're not taking the interest and pocketing it. You're not just, you are reusing the interest. Okay? All right, so let's look at their table. So the table they'd have for 8 years and compare. Okay? So theirs goes, we know this, 5,000, 1.09 cubed, 5,000, 1.094, 5,000, 1.095, 5,000, 1.096, 5,000, 1.097, 5,000, 1.098, and so then in general it's 5,000, 1.09 to the n. So those values, I'll pause it after I write them if you want to get these down. 5940, 6475, 15, 7057, 91, 7693, 12, 8385, 50, 9140, dot 20, 9962, 81. Okay, I'll pause there for getting those down. All right, so going on here. Okay, so this part I'll just kind of skim through. The biggest thing you got to get from this is it's principal times 1 plus I to the t. That's your compound interest formula. Principal plus 1 plus I to the t. Okay? Yeah, 1 plus I, right? The interest rate plus 1. So if it's 6%, 1 plus 6%. Okay? All right, so then we have exponential. So this is just a one we did. They just want the equation for the one we did would be 5,000 times 1.09 to the t. And just so you know, like I'll plot this roughly what I have on here, but the simple interest, we'll do simple interest in red here. The simple interest is simply was going to be, I'm not going to plot these two exact, but simple interest 1 was 5450. Yeah, essentially kind of just goes like this. Simple interest is linear, right? Because it just did 450 every time. Okay, compound interest is not linear. Okay, compound interest, it starts on the same track, pretty close, but it slightly goes slightly above and just curves a little bit at the end. You start to see the growth take off a little bit as it gets to the 99 there. So this one's actually a little lower. I'm just kind of guesstimating it for time here, but the compound interest one is just kind of slowly curving. You can kind of barely see the curve, but it's going to start growing faster because as it gets higher and higher in terms of how much money you have, that compound interest is going to build faster. So this gap between these two lines will keep building. That's the important part to see. Okay, that's just a rough sketch. If you want to plot the points, you can for more exact. I just did that for the sake of time for the video. Okay. Okay, we've got a couple examples here, and then we're going to be done with lesson 2. Okay, so compound interest formula, we already got this. I just wrote it for you. A equals P times 1 plus I to the n. Okay, so annually, compounding period. So number of compounding periods per year. If it says annually, that means how many times? Once, semi, twice, quarterly, 4, monthly, 12. There's one thing that we want to keep in track. Okay, total number of compounding periods. Okay, total number of compounding periods. So if it's going to be for, this one's for 5 years, it's 5 times 1, right? So 5. 5 times 2, 10. Where did I get 5? It's right here. $1,000 invested for 5 years at an annual interest rate of 6%. Complete the table to calculate the final value of the investment compounded according to the period and given table. Quarterly would be 20, and then monthly would be 60. So then we have to remember for interest rate, and we did this already, we do have to divide by the number of compounding per year. So if you're doing annually, that's just your interest rate's just 0.06, right? But if you're doing semi-annually, it's going to be 0.06 divided by 2, which is your 3%. Quarterly, 0.06 divided by 4. Monthly, 0.06 divided by 12. So this one would be 0.015. This one's 0.005. Okay? And these are our i's for the formula. These are our i's. So they change a bit because we're doing it more times than once a year. Okay, that people forget that. They always think they just put 6% every time. Okay, so here we go. Here's formula. So it's P. So principal is 1,000. So 1,000 times 1.06 to the 5th. 1,000 times 1.03 to the 10th. Because it's, remember, semi-annually. So that first one and the second one, it's 6% for the year. So it's 6%. This is 6% annually. So if you're doing it twice, you have to divide it. Yeah. 1,000, 1.015 to the 20th. And then 1,000. Remember, this is the number of times, so you still use these numbers, your exponents. Okay? 1.005 to the 60th. And so then those, when you calculate those for those totals, you're going to see the growth here. 1338.23, 1343.92, 1346.86, and 1348.85. So you see there's not a ton of difference, but you do see the more times you compound, you're gaining a little bit. You see that? Because remember, this is the same amount of time, the same amount of percent, but by compounding, having more periods of compounding, it gives you a little bit more money. Not much, $5, $3 to $2 more. So it's just a little bit of growth each time. Okay. All right. Everybody have that table down? You want to pause it? Close? So in example 3, we have 7,000 is invested in a 6-year GIC compounded quarterly at a rate of 5% annum. Determine the value of the investment at the end of the term. So we don't know this. We're finding this. Okay? We know our principal. Our interest rate is 0.05, but we're going to divide that by what? 6. No. 4. Quarterly. Our N is going to be 6 times 4. 24. So we have 24 periods. So that's all we need. We're ready to calculate. 7,000 times 1.05 divided by 4. Let's just put the number here. When you do 0.05 divided by 4, you get 0.0125. And then we're going to do the 24th. Yep, just like that. This will give us our how much we've made. And when you do that, you'll get 9,431 and 46 cents. 9,431 and 46 cents. Okay. Yeah, still not too bad. Yeah, the interest you need to divide by how many times a year you're applying it. Okay. All right, so last couple here. This one, Christine invested $2,500 for 4 years, compounded semi-annually, and received $843.26. What was the annual rate of interest? So now we are given A. So this is where we're solving for essentially a different variable. Okay? But what we do have to do, A isn't 843, is it? I have to add this to 2,500, right? Okay, so for A, it's going to be 33 33.43. And 26 cents is my A, because I have to add what she made plus her principal. Yep, P is still 2,500. Okay, and then we know the time is 4 years, semi-annually, so it's 4 times 2. So 4 times 2, we know that's going to be 8. Okay, so we have everything but I. I is what we're solving for. And it's actually going to be I over what? I over 2, right? Semi-annually. So we're looking at I over 2. Good? So then what we're going to do is we're going to go 3, 3, 4, 3, 26 equals 2,500 times 1 plus I over 2 to the 8th. That's your setup. One's always there. 1 plus, right? 1 plus interest rate. So what's our first step to solve here? Yep, divided 2,500. Okay, so you divide 2,500. You can leave it like that, or you can get the decimal. It doesn't matter. But we do have an 8 here. So it's like a lot of people are like, oh, let's log both sides. But we don't have to, because we know what to do with an 8, right? Well, how would you get rid of something to the 8th power? 8th root, right? So you still just 8th root. So we're going to go this right here. Just because 8th root's weird, you can write it as to the 1/8, or you can do 8th root, doesn't matter. But your calculator, you put in a bracket like this, and you put the exponent as a 1/8, that will get you the 8th root. You can, it's just make sure you use the answer your calculator because if you don't want to round too much, okay? But I think you'll be more exact if you do it like this. And then you have 1 plus I over 2. And so then that value you're going to get when you do this in your calculator, that value right here, this is going to be 1.037. So you get 1.037 equals 1 plus I over 2. And so now what do? Subtract the 1, and you can kind of start seeing things. You get 0.037 equals I over 2. And then multiply by 2. And so you see it's going to be 7.4%. 0.074 equals I. So I equals 7.4%. So the rate they had was 7.4%. Okay? Times 2 because it's semi-annually. No. Right. When you're solving, you got to add, subtract first. Yeah. Okay. I guess technically, Aiden, if you times everything by 2, it would work. So if you times this by 2 and the 1 by 2, didn't work. But it's a little bit messy. Okay, last couple here. Barbara invests $8,000 in an account which pays a compound interest of 6% annum, compounded monthly. How long would it take in years and months for her investment to double in value? So we want her investment to double in value, so we're going to go 16,000. Her principal is 8,000. We know her interest, and it was compounded monthly, so it's going to be 6%, 0.06 divided by 12. And we're trying to figure out number of years. But we know it's going to be 12 times the number of years, right? Okay. So now this one, we're going to need to use our logarithm stuff from lesson 1 for applications, the one before, because we're going to have an n in the exponent. Okay. So we're going to have 16,000 equals 8,000 times 1 plus 0.06 divided by 12 is 0.005. And then we're going to have to the 12n. All right, so let's see here just a second. Okay, so in years and months, so what we're actually going to do is we're just going to solve, and when we solve, understand we're solving for monthly. Okay, so I'm going to get rid of the 12 because that just, they didn't use it, so just I'll stay consistent with the book. So if we kept it like this, what would we be doing actually? It's not a big deal. We're solving for years, right? I'm making that in years. And they said to solve in months, so I'm going to take the 12 off right now, okay? That's all that we're changing. So it's not a big deal. It's actually just going to make the math a little bit easier. So, okay, so we're just going to solve for months, not a problem. So now we're going to divide the 8,000 over, so we get 2. So we get 2 equals 1 plus, or we can just write the number now. We don't have to write 1 plus. It's going to be 1.005 to the n. And so now, you could do the log both sides, but actually it's probably easier to write it in log form, right? So write in log form, it's going to be log base 1.005 to the 2 equals n. And now we can just change a base. Log 2 over log 1.005. That's what you want to calculate. When you do that, you're going to get 139. Nice. 139 months. So if we want to know how many years, divide that by 12. So that comes back to what we started with a little bit ago. So if you divide that by 12, you're going to get 11 years. Is that right? 11 years, 7 months. Okay. 11 years, 7 months. All right, one last one here. Borrowing money, yep. All right, so when an amount of money is borrowed, it's charged, used money for a certain fixed period of time. The loan's paid off in one payment at the loan, then the compound interest formula can be used. If repayments are made on a regular basis during a period of loan, compound interest cannot be used. Okay, so one thing, just like a quick, just off-the-cuff conversation here. If you ever have a credit card, right? Credit cards, obviously, you're paying interest on those. The one thing that I always play with in my mind, just because obviously I'm a math teacher, I like that, is that whenever we have credit card debt, I want to think about, well, how much am I being charged a month? Because what they do is they add your thing monthly. So they use the 12-month thing, right? So what happens is, let's just say you have $1,000 on a credit card. Okay, most interest rates are between 15 or 10 to 20%. So let's just say 20% on the high side. So if you have 20%, how it works is it's the APR, so it's an annual percentage rate. So if you take 20% times 1,000, what's that? 200. So that means for the year, if you have to leave $1,000 on that card, it's going to cost you $200. Okay? But what it means monthly is you divide 200 by 12, and that's what they're adding to your account. So they take that $200, they divide it by 12, so that's going to be roughly just probably 20 bucks. Okay, not too much for $1,000, and they're just going to add that to your principal, what you owe. Okay, so just keep that in mind if you have a credit card. So then obviously when you're doing things, like obviously when I moved, you have to use credit cards sometimes to pay for things, and then you want to get those off there because the bigger that is, the more they're going to charge you, right? Because the interest rate is just going to make that a little bit more money for them. But anyway, Andrea borrows $7,500 from her parents to buy a new car. Her parents charge her interest rate of 4%, compounded quarterly. Tough parents. Okay, when she pays off the loan, she pays $785 in interest. What was the length of the loan? Okay, so we're finding how long did she borrow. So we know that she paid, yeah, say it's a rough crowd. So we know that she paid $785 to her parents. Okay, so that means she paid total back of those two. So that's going to be $8,255. Yeah, $8,285. So $8,285 is my A. My principal is $7,500. My interest rate is 4%, and then it was paid back what? Quarterly, so that's divided by 4. So that's 0.01. Okay, and then N is what we're trying to figure out. How long? Okay, so here we go. We got 8285 equals 7,500, 1.01 to the N. Divide the 7,500 over. Like that. They just leave it in there, okay, because what we're going to do is we're going to go ahead and log again. So we're going to have log base 1.01 of 8285 over the 7500 equals n. And so we're going to do the change of base again. Oh, sorry, it's 001, isn't it? Or no, it's just 01. That's right, sorry. Okay, 1.01. And you do that calculation, you're going to get 10. And then what does 10 stand for? This is where it gets a little tricky. Right, it stands for quarters. So that's 10 quarters of a year is how long it's going to take her. So think about 10 quarters. Just think about 10 times a fourth. How many quarters is that? Or sorry, how many dollars is that? Think about money. 10 quarters. $2.50. Yeah, so 2.5 years. Yeah. So 10 quarters. Just think about that's what that means. And the last one we kept in months. This one's kept in quarters. Okay. All right. So that's it for this one.